Hey Matrix, welcome to the last video in the chemistry playlist. Today I'm covering question 10 of the November 2020 past paper. If you don't have the paper, there's a link in the description down below where you can download the paper, and then we can continue with the question. Okay, let's get started with question 10. Okay, so there's a flow diagram below that shows how fertilizer B is produced in industry. Okay, so we have two raw materials coming in. We've produced nitrogen and hydrogen. Okay, so that should give you a hint on what we're doing in this first process over here. Then we produce something with nitrogen and hydrogen. Okay, and then step 2 or process 2, we then produce nitric acid and then fertilizer B. Okay, so two main processes that you should be thinking of here is the Haber process and the Ostwald process. Okay, now let's start with 10.1.1. So it says name of S. Okay, so the raw material coming in at S is going to be the main source of nitrogen. Okay, so what has the most nitrogen in it? Well, it's just liquid air. Okay, since most of the air that we breathe in is mainly made up of nitrogen. Okay, now 10.1.2 says the name of T. Okay, so what is the second raw material coming in here to produce hydrogen? Okay, so hydrogen is a byproduct of another process which we use to produce coal or otherwise natural gases or oil. Okay, so over 10 the raw material for T we can then call coal or oil if you want, whichever one you prefer. I'm going to call it oil. Okay, so when they produce oil, hydrogen is a byproduct. Okay, now 10.1.3 says name or the formula for the catalyst used in process 1. Okay, now when we produce compound A, which we'll get to now, there's a catalyst that's involved in order to help bind nitrogen and hydrogen together. Okay, and that catalyst is iron. Okay, so Fe. Okay, now 10.1.4 says name or the formula for compound A. Okay, so compound A is the final product that is produced by the Haber process, and this is ammonia or NH3. Okay, so that's what the final product from the Haber process is. Now 10.1.5 says name the process for number 2. Okay, so now we're taking NH3, which we just formed over here, okay, and now we're producing nitric acid. Okay, so the production of nitric acid, you should recall, is your Ostwald process, where we take NH3 and use it to produce nitric acid. Okay, so process 2 is known as my Ostwald process. Okay, now if we look at 10.1.6, it says write the balanced equation for the formula of fertilizer B. Okay, so fertilizer B that is being formed here is going to be NH4NO3. Okay, so we're taking the NH4 over here, we're taking the nitric acid, and we're adding them together, as you can see over here, to form fertilizer B. Okay, so to write that out, we know we're going to have NH3 from the Haber process. Okay, bring that down. Then we're going to produce nitric acid, okay, which is HNO3. Okay, so now we just have to make sure that everything is balanced. So I've got 1, 2 nitrogens over there. I've got 3, 4 hydrogens, and then 3 oxygens. So my final product is then going to be let's have a look here. It's your NH4, okay, NO3. Let's have a look. 2 N's, 4 hydrogens, and then 3 oxygens over there. Okay. Now looking at 10.2 says a 20 kilogram bag of fertilizer is labeled as follows: 2 to 4 to 3. Okay, this is your pK ratio. Okay. Let me just get the exact name here. So it's your NPK ratio, sorry. It's your urea sulfate and your potassium chloride, which is put into that ratio over there. Okay, so Then it asks, what does the ratio of the label represent? Okay, that is your NPK ratio for your fertilizer. So that's your NPK ratio. Okay, so N is your urea, P is the potassium, not potassium, sorry, your superphosphates, and then K is your potassium chloride that goes into it. Okay, now 10.2.2 says the bag contains, okay, wow, that's quite a lot, 2.315 kilograms of phosphorus. Calculate the value of X. Okay, so we need the value of X here for the total amount of everything. Okay, so let's have a look here. We have a total of 3 plus 4 is then 7 plus 2 is 9. Okay, so the total there is 9 for everything. So we technically have for N, we have 2 over 9. For P, we have 4 over 9. And then for K, we have 3 over 9. Okay. Now, because we're looking for X, we can take as follows. We can assume a 100 gram sample. So what I'm going to do is I'm going to say that we have 4 over 9. Okay. Now what we're going to do is we're going to multiply it by X over 100. Okay. Because we're going to take a 100 gram sample, or we're assuming 100%. And then we're going to multiply that by 20. Okay, which is then going to equal to what is given to us, which is 2.315. Okay, which means now if we solve down, okay, remember this 20 is the 20 kilogram bag. Okay, so out of the 20 kilogram bag, we want to know what is the ratio of 100 regarding the superphosphates. Okay, so if we sort out all the algebra here, you'll get an X, which then equals to 26.04, which means you can then round that up to X equals to 26. Okay, and that's how we go about doing this question. If you found today's video helpful, then please leave a thumbs up on the video. If you have any questions or comments, please leave them down in the comment section below. I'll get back to them as soon as I can. Please consider subscribing to the channel as well, and remember, it's never too late to have an OIC moment.